Hi, I'm Birgit Woods, a technical analyst at Geosoft, and in this video I will show you some of the new capabilities we have added for working with geophysical sections. These capabilities are included as part of the geophysics extension for Oasis Montaj. Geophysical sections are often based on surface or airborne geophysical survey lines, which may be straight, but are more often slightly bent, bowed, or skewed. In some cases, they can even be tortuously meandering, which occurs when surveys are taken along roads or creeks. Here are some examples of how geophysical survey lines appear in the plan view of a map. The maps show an airborne MAG survey, an EM line along levees, and an example of a seismic survey. In each case, you can see how the survey lines are crooked or contain bends along their length. Typical data types used in geophysical sections are from IP, EM, resistivity, GPR, and seismic surveys. Sections may also be extracted as slices through a 3D voxel model. The GPR and seismic data are imported into Oasis Montaj using the SegWi reader. We now support the creation of sections for these crooked lines, thus the name Crooked Sections. We support them in new 2D section views and correctly geospatially positioned in 3D views. This ensures that your data are correctly positioned and not simply an approximation to a straight line. Let me show you how easy it is to create a crooked section. To create a section from a line in a database, you need X and Y coordinates along with two array channels, one containing the depth values of the data and the second containing the data that you want to display in the section. The geophysics extension for Oasis Montaj 7.2 includes a new section menu that contains all the steps for creating and viewing sections. The section generated is based on the current line in the database. We have the option to make a section of the entire line or just the segment of the line that you are interested in. In this example, we will plot a portion of the line from 5 kilometers to 15 kilometers. We'll select the data array, the channel that contains our time domain, the EM data, and the channel that contains the depth array. The section tool supports both positive and negative depth values. If you are using negative numbers to represent depth, tick the negative depth box. You may fit the section to your surface topography by specifying an elevation channel. In this example, we will just plot the section with depth. We also have the option of plotting a specific vertical range. In this case, we will choose to plot our entire vertical range. We have 4 different options to display the data. The 3 gridding options are minimum curvature, inverse distance weighted, and direct grid. Grids are not able to fold back on themselves, so in cases where the line turns back on itself, you will need to use the new pixel plot display option. The pixel plot produces a grid-like output, but draws a rectangle around each data point, which, unlike gridding, preserves both the original location and data values. Now let's set up a new section map. The section and default view names are based on the line name. For our section, we'll select a landscape ledger page. There are other options available for our section layout. For example, the size and position of the view on the page. These are particularly useful when plotting your section onto an existing map. We can also change how the reference grid is plotted. For example, we can change the reference grid color to light gray. Finally, we can either accept the automatically determined scale or enter our own scale. We'll use the predetermined scale and display our section. The sections are fully aware of their geospatial location. As I move the cursor around my section, notice how the X, Y, and Z coordinates in the status line at the bottom of the Oasis Montaj window track the cursor's location. Your section view is linked to all other views of your data. databases, profiles, maps, and 3D. One of the other new capabilities of Oasis Montaj is that all the data views within a single map are also linked. Let's take a look at an example that contains data from an EM inversion. Note how the cursor tracks along both the section and the plan map. We have displayed the data using the pixel plot method. We can zoom in to view the model blocks. You add interpretations on the section by simply drawing on the section map. Create a drawing layer on the map and then digitize the feature you would like to highlight. We then export this to a 3D DXF file to display it in the 3D view. Now let's see how we can display this in a 3D view. You can display a Cricut section in a new or existing 3D view. I'll open a 3D view I've already created and display the section. The view already contains a digital terrain model of the surface. We'll create and display a section based on the current line. Remember that if your sections bend back on themselves, you will not be able to display them as grids in 3D, but you can display them using the pixel plot option. We'll now import the interpretation we digitized a moment ago and see it in our section. First, I'll browse for the file, and then specify the coordinate system, which I can copy from the database. Note that the interpretation follows the crooked angles of the section and maintains its geospatial position. Now you have seen how you can easily create sections based on crooked or curved lines while maintaining their true geospatial position. And you've also seen how you can display these sections in a 3D view. If you have any questions or would like to know more about crooked sections, click the link below.